So the process that I talked about, called the substitution method, says that we can substitute for any variable that's solved for. So what we're going to try and do is more algebraically try and solve for a specific system. And what I mean by that is I need to make a decision, and this is going to be something that you can do multiple ways, but it doesn't really matter because every way is going to work out if you do the algebra correctly. I need to find a variable that's easy to solve for. Okay, so I gotta find a variable that's easy to solve for. I don't know exactly which one it would be, but you can see here that this y doesn't exactly have a number in front of it. So I'm going to pick that one. This one right here. I'm going to pick that one right there to solve for. Now you might say, well, why am I doing this? Well, I'll show you why. So I'm going to solve for this. I'm going to subtract it. And it's going to seem a lot like what we just did for graphing. So y is equal to negative 3x plus 5. Now, what the substitution method says is that anytime I see a y, I can replace it, with what it's equal to. So this right here is what y is equal to. It wouldn't make sense to substitute it back in here. So I'm not going to use this equation anymore. I don't want to use that first one. So I'm going to take this next equation, and instead of seeing a y, I'm going to replace it with what y is equal to. So instead of 4x plus 5 times y, I'm going to use a substitution property that says I can substitute something in if I know what it's equal to. So I'm going to replace y with this whole thing. And that's going to equal, I just replaced y with this, 3. Now it looks like a long drawn out equation, but what I did was I replaced y with what y was equal to, so now I only have one variable. So there's only one variable left. There's only one variable left. I can solve for that variable. Deal with the parentheses, the distributive property. So I have 4x minus 15x plus 25 equals 3. Minus 11x plus 25 equals 3. I'm going to minus the 25 over to the other side. So I get negative 11x equals a negative 22. Divide by a negative 11. And I get x is equal to a positive 2. So that's what x is equal to. Now I don't know what y is equal to, but if I plug it back into this equation here, or either of the two equations I started with, I can find out what y is. So y is equal to, well, we just got done saying that it was equal to a negative 3 times x plus 5. So it's a negative 6 plus 5, which is going to equal negative 1. So my answer for this is negative 2 comma negative 1. And that is my solution for this equation. So if I plug it into this, it's going to work for both ordered pairs. So I jumped ahead to the next page, and I'm going to look at the next one. And again, we're using the substitution method, so I'm going to pick a variable. And it just so happens that if you pick this y, it's probably going to be the easiest to solve for. So I'm going to solve for that y. So I'm going to take this equation, I'm going to subtract 3x. So I get y is equal to a negative 3x plus 2. So now I have this solved for y, so I'm going to take this first equation and I'm going to replace y with what it's equal to. So I have 6x plus 2 times y. Well, y was this whole thing, so I'm going to replace that with y equals. So negative 3x plus 2 equals 8. So solving this, I'm going to distribute. So I get 6x minus 6x plus 4 equals 8. Well, if you notice here, we have a 6x and a minus 6x, and they can cancel out. And I'm left with 4 equals 8. Well, that's not true, so what does that mean? Well, that means that this doesn't have a solution. In terms of this, 4 will never equal 8, so that means that there's no number that you can use that will work for this. So there's no ordered pairs that work for this system. So that's an example of something that doesn't have a solution. Or it is inconsistent. So what I need to talk about now is how you deal with something like this. Again, very similar. I'm going to pick this one here. So 3x, it's not always going to be x or y, or excuse me, it's not always going to be y. It's just been y in this case every time. So I'm going to subtract y, or excuse me, I'm going to subtract 3x to the other side. So I get negative y equals negative 3x plus 3. So I'm going to divide by a negative 1 because I want to get rid of this negative. So I'm left with y is equal to 3x minus 3. So this is what y is equal to, so I'm going to plug that into the second equation because I solved the first one. So I have 6x plus 3 times y. Well, 3 times y, or 3 times 3x minus 3, equals negative 4. So I have 6x. I'm going to distribute this 3 to both terms. So I get 6x plus 9x minus 9 equals a negative 4. So I have 15x minus 9 equals a negative 4. I add 9. So I get 15x equals positive 5. Divide by 15. I get x is equal to 1/3. So the x coordinate is a third. It's a fraction, but it still is possible. So now I got to take and substitute it back into this equation here. Doesn't matter which one I pick, but I'm just going to pick the one we solved for. So y is equal to 3 times a third minus 3. So 3 times a third is 1 minus 3. That's a negative 2. So my ordered pair is negative, or 1/3, comma, negative 2.